So let's start again. Thank you for coming. This talk, your website is running code that you've never seen. So you can see I'm kind of doing this a little bit on behalf of the company, but it's not really about us. It's about kind of a lot of the research that I do as part of my job. And we've seen attacks using JavaScript over the years, and they kind of seem to follow these patterns where they'll pop up and trend in popularity. We'll see a whole region of attacks, and then they seem to kind of die off and tail back down. And a lot of attack patterns follow this kind of process. And right now, looking at the data, we're kind of at the beginning of an upward tick. And I don't know like how far upward this tick is going to go, but we're definitely starting to see right now like the rise again of people revisiting these kinds of attacks. And they all start with something like this, right? Like we all know what a JavaScript tag looks like. So quick poll of the audience. Who uses third-party JavaScript on their website? Okay, there's a couple of people at the back not being honest, but we'll go with that. That's like 95% of the people here, right? And we all do this. Like everyone has script tags like this. It's super, super common. We've got like marketing, tracking. We've got A/B testing tools. We've got monitoring. We have, if you're in the finance sector, there's loads of fraud detection tools. And we all, as organizations, as websites, we all pull heaps of this third-party JavaScript into the page. But it kind of bypasses a lot of the traditional protections that we have in place. So if we were to think about your server, right, developers come along, they want to make some code changes. They are going to create a PR, there's going to be review processes, there's security testing, maybe unit regression testing. There's all kinds of focus on getting code into the application and securing the pathway to get code into the application. For the servers themselves, we then have antivirus, anti-malware, there's data loss protection, there's strict access controls, right? These things are super, super locked down. And I think over the years, we've well established all of the stuff that we need to do on the server side of this diagram in order to secure, ultimately, the page that we're going to be sending to our users, right? Because we want to make sure that the thing that we're sending out is secure, it is safe, that people can use our application, navigate our site, maybe do their online banking, maybe we're an e-commerce store, maybe we're a medical organization and we handle some kind of sensitive data. And we want to make sure that this process is pretty locked down. And most of the time, most organizations would say, we know exactly what code we're running, right? We have all these controls and change control and review processes. It's all super locked down. And then we send the page to the browser and this happens, right? And we start dynamically pulling a whole bunch of code dependencies, usually from third parties, and loading them into the page, and then they start running. Now, I have this conversation a lot. I do a lot of our enterprise customer onboarding when they're coming on board to use our product. And I was having a conversation recently, and we were talking about chatbots. AI chatbots seem to be like a huge kind of rage at the moment, right? Everybody's loving AI. I get it. And they're like, we want to add this AI chatbot. We're going to add this AI chatbot to the site. And I was like, okay, we can control this and when it loads and what it does. I was like, but, one of the problems that we have is when you load that code in, it has access to everything on the DOM, right? You pull that script into your page, it can interact with the DOM, it can read the DOM. And they were like, well, it can only read what people type into the chatbot, right? And I was like, no, that's not quite how that works. I was like, you pull that script into the DOM, the thing has access to your whole origin, everything that's in there, right? Including things that the users are typing. Obviously, that's how a chatbot works. It can see the key presses. And they're like, right, but it can only see the key presses when you click on the chatbot. And I was like, no, it can see the key presses when they're on another element on the page. Hopefully, they're not looking at that, but it can. And it's not even just user input. If the page just loads sensitive data, if I go to a medical website, right, and it loads my prescription history or my treatment history or something, I was like, well, the chatbot can read that. The chatbot can see that if it wants to. How do we know that it isn't? And this is the problem with all of this kind of third-party code, this huge oversight that I see, this misunderstanding of it has access to everything. If it's loaded on the DOM, it can see it. If the user types it in, it can read it. If the information is there somehow, it can be accessed by this script. And especially when this is third-party script that we're not necessarily in control of, the problem then starts to get much worse. Now, I wanted to look at just how bad the problem is, right? I did a quick poll there, see how many people are using third-party JavaScript. Probably 95% of the room or something like that. And I was like, I wonder if we can get some actual reliable data on this. Rather than just conjecture, what do the actual numbers tell us? So I went to a project called the Web Almanac, and they do this survey every year of the top millions of websites in the world, and they analyze all kinds of things, including security stuff, but also just accessibility things, page weight, like resource types. And I've been tracking for a while now and this is the median page load of JavaScript. This is not the average, this is just the median. Right? So the median web page for desktop browsers last year was loading 680 kilobytes of JavaScript alone. It's only second to images, right? Like the heaviest resource on a page is images, but we can kind of all understand that, these super rich content items. But they're the only thing that can beat JavaScript based on the weight on the page. And this is a staggering amount of code that we're loading in dynamically, basically at runtime. Like we have no visibility of this on the server. It's all happening out in the browser. And when we look at that as a graph, it's kind of shocking when you look at this and think, so over there on the left-hand side is the actual page that we wanted to load, right? This tiny little thing. We've got some CSS and some fonts to make it look pretty. And then we get to the second largest item on any page is JavaScript. We're loading in all of this code. And looking at the statistics for the crawl, across tens upon tens of millions of pages, 98.1% of them are using JavaScript. So when I say like everybody's doing this, I'm not trying to exaggerate that point. The data shows us like everybody is doing this. And I was like, okay, but 98.1% of pages are using JavaScript. Maybe they're loading their own JavaScript. Maybe it's their own dependencies. What we really need to look at, because you can control your own JavaScript, we need to look at third-party JavaScript. Like how much of this is actually coming from another party, another person, another origin. So we have the numbers of this as well. So I decided to take a look at, on those pages, what is the typical number of third-party requests on a page, right? So the page rank down at the bottom, this is their popularity rank, right? So the top 1,000 sites, then we've got the top 10,000, the top 100,000. And again, we're looking at the median numbers, not the average here. We're looking at the median number of third-party requests on the page. And apparently, like, the more popular your website is, the more likely you are to make more third-party requests. Maybe there's some interesting reasons for that. But this is a lot of third-party requests just to load a page, right? We load the page, we go to your site, and we're communicating. If you're on a popular website, you're talking to well over 100 third parties with those requests. And then I was like, okay, but what percentage of these third-party requests are JavaScript? This is the question. It turns out that JavaScript is the #1 thing requested from third parties. Right? It beats everything else. It beats even things like images, these big, heavy, media-rich assets. We're pulling in more code from third parties than anything else. It's like, this is kind of crazy, right? Like, all of this code is coming in. And if we're being honest about it, we have no visibility. You put that script tag onto your page, it goes into the browser, and then the browser's pulling that dependency in real time, completely out of our visibility. We don't see this, we have no insight into this process, right? So it is the #1 thing that we're loading from third parties, is code to run on the page. And this is where the problem comes in, because now, once we pull that script into our page, we don't really have any control over what it's doing. In that kind of default position, you pull the script in, it's a chatbot. I know what it's supposed to do. I know what I want it to do. I know what I don't want it to do as well. But we're hoping that the vendor kind of sticks by their promise. We're going to give you a chatbot. It will be awesome. Nothing will go wrong. And you're hoping that that's the case. You're hoping that when the browser loads that script, it does what it's supposed to do and doesn't do anything that it's not supposed to do. But like I say, it can read anything in the page, right? If you've got sensitive information in there, keystrokes from the user, it's all available to this script. And this is then the problem, because what these attackers seem to be realizing is it's now much easier. If you're quite a big organization, a financial institution, government department, something like that, it's going to be reasonably difficult to compromise your application, to compromise your servers, to, if they want to steal a bunch of customer data to get in your database. And what they're doing now is they're looking at your third-party dependencies and being like, oh, this company here, this isn't a multi-billion-dollar bank. This is like a development company with like 20 staff members. I wonder what their security budget looks like. Is it going to be less than the banks? And the answer is probably yes. Like, they probably spend less on cybersecurity because this bank has a cybersecurity budget that's like the GDP of a small country, right? This 20-person development house doesn't have the same cybersecurity budget. But if you can compromise this dependency, and you can add your malware here, your keylogger, your data skimmer, your drive-by download, whatever it is, and the bank is loading this dependency into their page, you kind of get the same level of access, right? Like you've seriously compromised that organization without actually going after them. And the question then is, how can the attackers compromise these third-party dependencies? And there's whole bunches of different ways there. We've quite literally, there's a big one we'll talk about soon where this company, the library vendor, they were just storing all of their assets in an S3 bucket for easy distribution. It's like a CDN endpoint, right? We assume the credentials were either too weak or phished, but the attackers managed to gain access to their S3 bucket, and they were able to append some additional JavaScript to the bottom of the libraries, right? And this was a text-to-speech plugin for visually impaired users. Now, it still works, right? You can still go, you click the button, it does text-to-speech, but it's also reading the data on the page as well. So the original functionality remains, it's still there. You just get some extra functionality on top. We've seen another one that I'll talk about. This happened in January this year, so like a month and a half ago. It was their Google Tag Manager account. So again, we presume either weak credentials or phished credentials, not 100% sure, but the attackers managed to gain access to their Google Tag Manager account. They can then add a new piece of script. The new piece of script goes straight into the page. Away we go. They're now running code in your pages. And these attacks are turning out to be like super, super trivial. So there's basically a whole bunch of different ways that this can go wrong, right? Ultimately, this file somehow needs to be changed or impacted or infected with malware. And you can do that any which way that you want. The problem is, when that script tag's on your page, the next visitor that loads the page is going to pull the new payload and the browser's just going to run it because the browser doesn't know any different. So yes, there has to be some kind of compromise at some point, right? That file needs to be accessed, the tag manager credentials, S3 credentials. Maybe your actual infrastructure gets breached as the third-party host, but there needs to be a point at which some kind of breach happens for them to inject this malicious JavaScript, this malware. And a lot of the ones that we're seeing at the minute, their focus is on either capturing keystrokes and keylogging and exfiltrating them, or skimming data off the DOM and exfiltrating that. So there's always then some kind of exfiltration component, because actually getting JavaScript into the page isn't immediately useful. Right, they've got to get the data out of the page to somewhere they control. So this is what the focus has been on. There's always some kind of exfiltration component, and they're looking at, some of them we've seen they were clearly targeting like usernames and passwords. I don't know what they want to use them for afterwards, but they were skimming username and passwords off the login form. A lot of them over the years now, if we go back and look at some of these attack groups, they really started to pick up in kind of like 2014, 2015. And the big focus for a long time now has been on payment forms, because they can skim the full credit card number as you're typing it, but they also get the security code and the expiry date as well. Right? So when you get a set of credit card details like that and you get the security code, you're then like, let's go, right? We can go start spending some good money with this. And looking at these over the years, a lot of these are just as big as the previous ones, and they don't seem to be making as much of an impact in the news headlines, right? Some of these attacks were enormous. There's one that we'll talk about on the next slide. It was massive, and it barely made the mainstream press anymore. I think there's just a little bit of fatigue of like, oh, this company got breached and lost like billions of dollars. Oh, well, Tuesday. It's almost becoming like too frequent. The most notable ones on here, like really big ones that made the most headlines, especially like Ticketmaster and British Airways. The British Airways fine from the UK data regulator, nobody else. Right, they ended up with 3 lines of JavaScript on their website that shouldn't be there, that was skimming data. Now, this is pretty bad because they handle like passports and other kind of really sensitive information as well. They got fined by the British regulator just for the British people's data that they lost. £189 million was the fine from just the British regulator. Right, Ticketmaster, they lost people's names, addresses, credit card information. They got fined £1.5 million by just the British regulator for just the British people's data they lost. And again, they ended up with a bunch of lines of JavaScript on their site that shouldn't be there. But the browser doesn't know. It's like, well, look, I load the script, I run the script. The script said, take all the data and send it over here. I got you. That's what the script says to do. So looking through some of these, again, year after year after year, all of these cost the relevant organizations millions of dollars, right? And it just continues. And we have these upticks and we have these downticks. And we seem to be on a little bit of an uptick right now. I don't know why the Bybit hack last year did not make more headlines than it did. Did anyone see this? Has anyone heard about the cryptocurrency exchange getting hacked? Right, they lost $1.46 billion of cryptocurrency. And it really didn't make that big a set of news headlines. And I'm like, hang on a minute, this is like mega money. right? They got JavaScript on the page that shouldn't be there. When you're doing a transaction, they change the address where you're sending the money. So on the visual end, on the UI, the user's like, yeah, this all looks good. Everything all matches what I'm expecting. Press the button, change it, goodbye. And this was almost $1.5 billion of cryptocurrency that was stolen because of a few lines of JavaScript, right? And I just can't understand. These last three here now, they're not actually public yet. So you won't see any news headlines about these because two of them are resolved, one of them is still ongoing. So again, unfortunately for Bank of America, third largest bank in the United States, they ended up with some JavaScript on one of their applications that shouldn't be there. They put too much trust in one of their dependencies, and they got some extra JavaScript they didn't want. Same for Canada Computers. I did the reverse engineering on this one. So this was like mid-January. And it was actually, when the malicious script payload was introduced, it was then scanning the rest of the DOM and looking for any other kind of like potential security toolings. It was finding like Google Tag Manager, removing it. And it was looking for other script tags further down to remove and pull out. So they were clearly trying to stop any tooling that might defend against the attack from loading. So yeah.
The reason for the Bybit hack, why it wasn't big, there was some other certain people in the news giving out about tariffs.
Oh, so Donald Trump drowned it out. Okay, that makes more sense. I was like, he should just, go hack a crypto exchange. It's like, we don't need tariffs. You can get $1.5 billion in crypto with like 10 lines of JavaScript. So yeah, the Canada Computers one was interesting because when their script tag came in, it was ripping through the DOM and trying to find potential like security tools. It was removing Google Tag Manager. It was removing the monitoring JavaScript. And it was like, I'm coming in first and everything below me is now gone. So this was interesting because they're now clearly seeing there could be things on the page that will detect us or stop us. So we're going to rip through and just take them out and make sure that we have unfettered access to everything. And right now, like I say, we're kind of on this, I feel like we're on this upward tick, and I don't know how steep the curve's going to climb or how high it's going to go, but we're definitely starting to see a rise in these kind of attacks again. Now, the question is, first of all, do we even fully understand what our exposure is? I work with all of the organizations that we bring on board as enterprise customers. And a customer will come on board and I'm like, right, the first thing we need to do is understand what third-party dependencies you have. If we're going to understand if something's wrong, we need to understand what's right. Like, what does correct look like? And we can go from there. So they'll come on board and be like, okay, yeah, no, we got this. Like, we have these 14 JavaScript dependencies that we use for all these different things. They're in our privacy policy and our cookie policy. We'll deploy our tool and we'll do the initial scan and the audit. And we'll be like, well, you have 17. And they're like, no, we have 14. Like, they're in our privacy policy. It's like, no, you have 17. And the amount of organizations that we onboard where they think they know like what tooling they have, what JavaScript dependencies they have, and they don't. And there's been multiple scenarios alone where they're like, okay, we just need to pause this engagement because we have to go speak to the legal and privacy teams because it turns out we need to update our cookie policy because somebody's added a bunch of tooling that didn't go through the correct processes and we didn't know about. This is such a common thing. And again, to go back to the original slide earlier, given all the controls we have on the server and on the application and code review, and we do a lot of work on dependencies on the server side now with like Composer and NPM. We've all seen the issues with like rogue dependencies in those platforms. We have absolutely nothing on these third-party JavaScript dependencies. So the first thing that we say to everyone on the way in is like, you've got to get some visibility. We need to understand where you are now if we're going to understand changes and differences going forwards. Now, we need that visibility in the client, right? Because that's where this JavaScript runs. That's where your third-party dependencies pull their fourth-party dependencies. So if you're going to look at this and say, we definitely understand the exposure, we definitely know what's going on, you have to do this in the client. You have to do this where the code is running. And we've even seen attacks where some of our customers' websites, they'll have a third-party dependency, gets compromised, introduces a rogue fourth-party dependency, and then depending on who fetches the file, you will get an infected or not infected version of the JavaScript. Right, so depending on who's requesting it, so if we try and pull it as an organization to do some analysis, they're like, here is the clean version for you. Right, but then you spin up a browser and load it in the client, and they're like, oh, this looks like a human in a browser. Here is the malware. So this visibility has to be in the browser because we need to look at what are our users looking at, what are our visitors looking at, because they're often different. So how do we do this, right? A few different technologies that we're going to look at to make this really easy. The first thing is content security policy. Right? I cannot overstate how powerful this mechanism is. But I'm just going to give you some like kind of quick hacks, because I feel like CSP is super frequently misunderstood, or people have a lot of difficulties with CSP, and actually you can get an enormous amount of value with very little work. So quick show of hands, just so I can pitch right. Who's heard of CSP before? Awesome. Right, so you all get the idea, this declarative policy mechanism, and everyone's like, okay, we must specify this list of all of our resources, and then if something happens, you know, the policy is going to block it, and then this resource won't work. And when I'm working with big enterprise customers, especially e-com platforms, they're like, we really don't want to break, you know, like the payment page, the basket, the checkout, because this is where we make all our money. And if we deploy this content security policy and we miss something or we make a mistake, we're just going to totally nuke our entire e-com page. So I'm like, first of all, right, forget about getting to enforce mode. The first thing that we need to have is visibility. So as you can see, we're going to deploy this policy in report only mode. So this is 100% safe, full like test mode, no impact, no blocking. And then what we're saying in the policy is there should be no JavaScript on this page, right? I'm going to declare script source none. So now what this is going to do is it's going to cause the browser to think there should be no JavaScript on this page. But actually, I found like these 14 dependencies. So I'm going to report them to you because this is wrong. All right, so now we're turning the browser into like an auditing mechanism to say, what dependencies are on the page? Please send me an audit of what you see. And then you can ask it to send those to you. Right, so you declare either the slightly older report URI mechanism, the slightly newer report to mechanism, whichever one you want to use, doesn't matter. And you're going to start getting things like this. Right, these are the actual raw JSON payloads that come from the browser to say, okay, well, you told me there should be no JavaScript on this website, and I found this piece of JavaScript here. Now remember, it won't actually be blocked because the policy is in report only mode, in this safe testing mode. But now, for each of the JavaScript dependencies on the page, the browser is going to send us one of these payloads to say, look, these are the dependencies that you have. So you can get immediate visibility from CSP. There's no risk in this. You're not going to break anything because it's in report only mode. And almost instantly, right, you can deploy this policy, and the first like 5 people that visit your website are going to send you that full breakdown of your assets. And you can say, right, we now know our full exposure in production. It includes first-party dependencies, third-party, fourth-party. If it's on the DOM, you get one of these. So we've been doing this for a long time, right? And it's pretty widely understood. I see a lot of people struggling to push themselves to an enforced policy, to a block policy, right? The majority of our customers have no intention of ever getting to an enforced policy because they're worried about breaking something. They're worried about a misconfiguration, a mistake. And I'm like, so forget it, right? Just stay on report-only mode forever because it's better that you have the visibility. And if a new dependency pops up tomorrow, as soon as your visitors see it, you're going to start getting those payloads to say there's a new script dependency on the page. It's better to have that instant visibility and change detection than to never achieve it because you were trying to push to an enforced policy. Right? We have huge amounts of customers that have no intention of ever getting to enforce mode, but they're like, you know what, if something changes, I want to know about it 4 seconds after it changes. So that's massively valuable. Now, the other thing that we started to try and do was to start fetching these assets ourselves so that we could do some analysis on them, right? What dependencies are you loading? What does the code do? What does it look like? And the vast majority of the time, this is all fine. But as you'll see in a minute, it's not always exactly fine. So looking at content security policy, quick recap before we move on, right? Just use it as a quick tool to get that full audit of the client-side dependencies. You want to know, what do we have? Shove the policy in production, collect the reports. You need to do this for like an hour. Right, there's like a few different visitors. If you've got geo-sensitive content, it will cover everything. You get all that data together, you've now got your full breakdown. Then you can track the changes over time. Right? If you get a new dependency, you're going to start getting new reports. If your fourth-party dependencies change, you'll get a report. So now you can do very, very quick change detection. And we call it near real time. Obviously, it's got to load and report to us, so there's like some seconds of delay. So we call it near real time. This is a cool one. So we have threat intelligence products. There's lots of them out there as well, right? You can take this list of JavaScript URLs that you're loading. You can even run it against like Google Safe Browsing, right? And just feed all these URLs into Google Safe Browsing and say, are any of these known to be involved in malicious activity? And if Safe Browsing comes back and they're like, yeah, this is a malware hosting domain, they're like, okay, we have an incident. We need to go do something, right? Super easy to enrich this data and make it more valuable. And as you want, like I say, you can block new JavaScript dependencies if you want to. You don't have to. This is the number one thing I see people being kind of put off by CSP, is everyone kind of thinks like you have to get to an enforced policy to get value, and you don't, right? You can get 90% of the value before you get to an enforced policy. So just focus on that. Now, the next problem we had is when those URLs come in and they say, okay, the client is loading this JavaScript, and we're like, okay, what does it do? Has the, you go fetch that JavaScript file, it's like, has it changed since yesterday? Because you're loading it from the same URL, but the file could be completely different from one day to the next to the next. So I'm like, can we load this file on a regular basis and see if there's any changes over time? If there are changes, can we take a look at the code and see what was different? And this works really well when you're loading legitimate JavaScript, right? Vendor patches the file, you pull the file, you can see the changes, you're like, okay, this all looks sensible. This doesn't work when they're trying to stop you from seeing the changes they've made. And this is when we started noticing that sometimes we're getting different JavaScript payloads when our servers, our application requests it for analysis versus when you load it in the browser. And this was then the next kind of problem, because it's like, well, how do you know if the browser says I loaded JavaScript from this URL, and then you go load JavaScript from that URL, how do you know that you're looking at the same code? And this kind of indicates the original problem is that you don't know. Every single time you go to that URL, it could be different JavaScript, and you wouldn't know. But we now have another new feature in CSP to help us with this. So in your content security policy, you can now add this report SHA-256 directive. And what you're saying to the browser is, every time you load a script file, and that script file comes into the DOM, I want you to hash it, and I want you to send me the fingerprint of the file. So now we can request that the browser, if you're going to run script, you hash it and give us the cryptographic fingerprint of the file and send that with the telemetry payload. So now, we can look at this, you can look at this and say, right, okay, somebody came to this page. It loaded this piece of JavaScript into the page, and this is the fingerprint of the file. So now if we go fetch that file, we can fetch it ourselves, we can hash it and compare it and say, we have definitely got the exact same file that whoever this user was that loaded the page, we've got the exact same file that they got. And now this gives us the ability to confidently say, the code that we're analyzing is definitely the code that your customers are running. It's not been changed, we've not been served a different copy. Because this is a big problem, like we started to see this, and it's like, they're just serving us a clean version, so we don't know what the file's doing. So this is a super reliable way of doing this now. And this, again, just like CSP, right? It's freely available in the browser. You just add the directive, and it will start sending you the data. There's no software agent to deploy, no license fees to pay here. Right? This is native browser functionality. Yeah?
Question. If I'm running my CSP in block mode,
yes.
can I also, because it's helping out the client, it's outside of my domain, can I also get a report, even if it's running in block mode, blocking and reporting?
Good question. So for the room and the video, if I'm running my CSP in blocking mode, if you're running your CSP in blocking mode, you won't get the hash because the script will not be loaded. So the important thing to understand is if you're in block mode, we don't challenge that script like after it's loaded and after it's run. It's like way before we've even loaded this script. It's going to look at your policy and say, can I load it? And if your policy says, no, you can't load it, the reason you won't get the hash is because we don't have any script to hash. Like we didn't even load it. So if you're in block mode, you will not get these for blocked JavaScript payloads.
We'll get the hash.
You'll still, so if I go back, you'll still get this one, right? So you'll still get the original violation report to say it was blocked. But what it will be missing is the hash directive in there because it's like, well, I have nothing to hash because I blocked it. So you'll still know about it, but we can't fingerprint it because it was actually never existed. So we can't get a fingerprint for something that never existed. But yeah, that's a really good question. So yeah, just add the report SHA-256 directive to your policy, and then for script that gets loaded, you're going to start getting these hashes to say, look, this is the code that we ran. And now we can start do things like change tracking over time. Right? If all of our customers are loading this today, here's the hash. They're loading it tomorrow, it's the hash. But the script at that URL here, it could change. And when it does, the hash will change. And that's going to be your first indication that one of your dependencies is effectively just done a code deploy to production. Right? Because they changed that dependency, that code is going straight into your production website. You didn't look at it or approve it or make that deploy happen. Right? They made that deploy happen. And now all of your visitors are being exposed to a bunch of new code. So now, if you want to, again, you could pull this asset and say, right, this is the one from yesterday, this is the one from today. What changed? Was it a good change, or did they get some malware appended onto the end of the file? But this, I kind of find it crazy. Like, this is the first insight that you're going to have that somebody else just did a code change on your site and deployed it, and it probably didn't go through any of your processes. And I bet the third-party vendor is probably not going to tell you. So this is a really powerful insight. Again, still no risk. We're still in report-only mode. Still hasn't cost us anything, right? And now we have all of this valuable information. So looking at this, the main thing with the hash value in CSP is being able to reliably say, we know what file, what code they're serving to our customers, to our visitors. We know for sure that this is the right one, right? If the file changes, the hash changes. So you've got immediate change detection on that file, that URL. Again, like additional things that you can do with this. So we've now got almost 13 million validated signatures in our database. So if you're pulling known libraries, known dependencies, things like that, we can cross-check it and say, even if the file name is a bit squiffy, we can look at that and be like, oh yeah, this is jQuery. We recognize this file. The fingerprint matches this known library. So you can then start to do kind of like known fingerprint recognition as long as you've got a big enough data set. The other thing that we then do is say, oh, you're using this outdated version of this library because we've verified it based on the fingerprint, cross-check, see if it has any known vulnerabilities. You've got something you need to go patch. So again, it's a really powerful mechanism that you can then start to add additional value on top, however you might want to do that. So looking at the way things are now, kind of like switching to the future focus of this, these are things that you could do. Some of these we already do, right? But you can start to fetch those files yourself. You can do code analysis to see what does the change do, right? Our vendor changed their code. What does it do? I mean, you could go read their release notes, and then you're kind of hoping that they've told you the truth and everything in there is correct. But you could go do this yourself, right? If you've got your own fingerprint library for your own internal libraries, for your own code, you can just say, okay, well, look at all of the files that we're serving in production. Do they match the ones that we think that we made? Right? So you just cross-check against your own library and say, yeah, nothing went wrong. All the files are good in the S3 bucket, wherever they are. We know that nobody's messed around with them. Nobody's changed them. Right? Super easy to do this. So then, yeah, if you want, you can then have file integrity monitoring on your JavaScript dependencies. Send me a notification when the vendor changes the file, when my users are getting new code. All of these things are easy for you to do. And there's still no risk, right? Nothing can go wrong here. Now, if you want to take this to the next step, there is another completely free and openly available technology in the browser called SRI, Subresource Integrity. Okay, so just again to feel the room, who's heard of SRI before? Okay, so slightly less, like maybe half the room. Okay, so Subresource Integrity ties in very nicely with the CSP integrity feature we've just been talking about. If you're loading a file from a third party like this, rather than just completely trusting them, if I want jQuery 12, right? I want to go load this file. Especially if the path is versioned, or you're expecting a static file to come from that third party, you can now just lock that file to its hash and say, look, when you go to this CDN and you download this JavaScript file, you pull it down and you hash it. And that should be the hash of the file. Because we want exactly version 7.9.3, and 7.9.3 should always hash to this value. So now the browser knows when I fetch that file, this is exactly what I should be getting. Now, the one catch here is that, of course, that file has to be static, right? You can only pin against a known version that is static. So if you have a dynamic dependency, which again is starting to hint at a bit of the problem here, we're loading this code that changes all the time. You can't say, I know what code I'm going to get and this is the code, because you're saying, well, this code changes all the time and I get different code, right? So that is kind of hinting at the problem. But if you're pulling static dependencies, this is absolutely the number one thing that you should be doing here, right? Lock against the known hash of the file. Because I understand the value in people wanting to pull third-party dependencies, right? It's like, well, the CDN's hosting it. We don't pay for the bandwidth. They're geo-distributed. We have shared caching in the client. Like, I understand that there are benefits to doing this. So we're not saying don't do it. We're just saying do it safely, right? Trust the third party to load the code, but verify the code that you're loading is the code that you're expecting. So just out of interest, like most of the times now, especially if you're pulling static libraries like this, a lot of those like valid reasons to do this are actually quite old. So for example, now it's not better for performance to pull third-party dependencies. If a lot of people will say, oh, there's shared caching on the client. If you look up HTTP cache partitioning now, you can't share dependencies across origins in the browser. So even if the browser's pulling the same library on 12 different sites, it's pulling 12 different copies anyway, even if they're coming from the same URL. Has anyone heard of HTTP cache partitioning? Did you know that the browsers changed that? So now, if if this was the exact same URL on my site, on Stefan's site, on Nal's site, on your site, you would think that the browser will share the same version of that file in the cache across the 4 sites, which is most of the benefit of using the CDN. They won't. So the HTTP caches are now partitioned per origin. So when it goes to our 4 sites, it will download 4 copies. Yeah?
And the question is,
Why does it do that?
why did they change it?
Privacy. So if I go to your site, let's say you loaded like a very unique URL JavaScript file, right? And then they come to my site and they want to load the exact same file. In JavaScript on the client, you can time how fast. You can, what did I do? What happened? If I wiggle the mouse, will it come back? If you time how long it takes to load that file, you can basically very easily figure out, was it in the cache or did it come from the network? So then if we're colluding, we can start to track users by putting these unique JavaScript files in the cache. And then when they go to my site, I can be like, oh, that loaded in 1 millisecond. It must have come from cache. So now if that URL is unique enough and we collude, we can start to do some pretty nefarious things. So they've separated the HTTP cache apart so that you can't do timing attacks against the cache like that. But then we look at other avenues as well, like HTTP2. So if you're hosting your own assets, the browser already has a connection open to you. The TLS connection's there, the TCP connection's there, DNS is already done. And with HTTP2 and connection multiplexing, you can request multiple assets through the same connection. If it's a third-party CDN, I've got to do DNS, TCP, TLS, HTTP, and then pull the asset. So it's actually worse for performance most of the time. I don't often talk about it because I don't want to be like, don't use third-party CDNs. But if you look at it, if you scrutinize it closely, there's actually very little value proposition for loading your JavaScript from a third party these days. Then there's the privacy concerns, if those matter to you as well. So, sorry, you made me get on my soapbox. I'll get back down off my soapbox. I'm trying to focus on this from a, being not getting on my security soapbox. So SRI, right? SRI is great if you're loading a static dependency. If you are loading a static dependency, 100% without question, you should be using SRI, right? And if you're not, go and change that. It's probably the best bang for buck you're going to get. The great thing is the only time you're ever going to have to update the attribute is if you go in and update the file version number. And you're like, oh, we're going from version 3 to version 4. We need to update the script tag. Well, at the same time, just update the integrity attribute to the new hash. There's no overhead. There's no additional work involved. It's completely free. It's fully supported in every browser. You can provide future-proof hashes as well. So, if you're going to put that script tag there with a SHA-256 hash, and that script tag's still going to be there in 10 years, we may have deprecated SHA-256 by then, right? So you can future-proof it and put the future hashes in there as well. And the browser will just always choose the best one that it supports. Fully backwards compatible. So yeah, any static, and this is the catch, right? It's got to be a static dependency. But again, by acknowledging that you don't have static dependencies, and then you can't pin against them, you're acknowledging you're running code that you don't know what it is. Because we can't say, I want this code. And that's kind of the problem. So then, if you wanted to use SRI, how do you prevent somebody from adding a new script tag without it in the future? How do you know if all of your existing script tags have SRI? Are there any that you've missed or that you need to go back and add it to? Well, we have another feature in the browser that, again, is widely supported and free to use, called integrity policy. So you can set a position on your site to say, for any script resources on my site that are suitable for SRI, I expect them to have SRI. And if they don't, then that is a problem, right? So you just declare this header. Again, we are in report-only mode. Completely safe, nothing's going to break, right? Perfectly safe testing mode. We are then going to say, look, we're going to block any scripts that do not have appropriate integrity data. If there is no integrity data, we're going to block them. Obviously, it's not. We're in report-only mode, but it's still going to send us the telemetry to the endpoint that we specify. And then, if the browser comes across an asset on your site that was suitable for integrity checking, but didn't have integrity checking, it's then going to dispatch you one of these reports, right? So it's going to say, look, I came to this page here, and I tried to load a script, because you can do this with styles as well, but most people only really care about scripts. And this was the thing that was blocked because it didn't meet the policy. Now, as you can see here, it says report only was true, so it didn't actually block this. But what it's telling you is that this asset is potentially suitable for SRI, and you're not using SRI on this asset. So now, You can use this as a quick discovery mechanism to say what's the exposure, what script tags do I have without SRI, and then you can go and fix them all, add SRI, and then you can monitor on an ongoing basis if somebody introduces a new script tag and it doesn't have the integrity attribute. You'll get the alert to say you have an asset that's suitable for integrity checking, but it's not being checked. Right? It's free, simple, it's in all the browsers, it's dead easy. So the main benefit for me is to make sure that either a new dependency is not introduced without SRI, or if an existing dependency has SRI removed, right? Both of those scenarios are not ideal, so you want to know about them. So you will get these reports coming from the browser to say SRI is in place and SRI can't be removed. And then now, going forwards, you can say, well, like we have the knowledge, we have the visibility. I know what our current position is, and if things change, I'm going to be told that things have changed away from my expectation. So this is super, super powerful. Now, the key point to add here is that this only triggers on JavaScript dependencies that are suitable for integrity checking, right? Because there are some dependencies that you will have that are not suitable, and it depends on whether or not the script is loaded with authentication, right? So we're talking about like truly static third-party dependencies that require no authentication. So if the script tag is required to load the third-party script with authentication, with cookies, then those assets are not suitable for integrity checking, because there's a very clear indication there that obviously the state is meant to change based on the user, whether they're authenticated or not, maybe based on their role. So it's only going to pester you about scripts that are actually suitable for integrity checking. You're not going to get a bunch of noisy reports about things that you can't do anything about. So this is a really kind of clear point to make here. So quick summary, right? Like all of the different technologies that we have available. The end of this slide is picture time if you want to go and take all these away as notes, right? Content security policy. Don't worry about getting to an enforced policy, right? I see so many organizations and they think, we've got to deploy CSP and we've got to enforce the policy. No, you don't. You can get 90% of the value of a content security policy with like 5% of the work, right? And that's good enough for the vast majority of people. So get a content security policy in place, keep it in report-only mode, and be perfectly happy with that, right? The new CSP integrity feature. Once you've got that policy in place, you can start saying to the browser, send me the fingerprints of the files that I'm running. I want to know like what those files are. And maybe you don't do anything with it actively, right? But when a problem spins up next week and you can go back and say, okay, yeah, this file changed on Tuesday and the problem started on Tuesday. Maybe there's a problem here, right? Maybe it's malware, maybe it's just a breakage, maybe it's a failure, something went wrong. But you've got the data. They're just JSON payloads. Stick them in a database and forget about them until you need them, and then they'll be there for you. Subresource integrity. Got to get this on your script tags, right? If you're pulling a static dependency, 100%, no questions asked. Go put SRI on all of your script tags. You can do this with styles as well, but people don't usually bother too much. And then the final one, integrity policy. So you need to know, are we using SRI on all of our script tags, right? If we can have this protection in place, do we have this protection in place everywhere? So you don't have to go crawl your site, you don't have to crawl your code base, you don't have to have someone check, right? Just get the browser to do it for you. If you load my page and there's something wrong, just tell me about it. And if there's nothing wrong, it's not going to tell you anything. So that's awesome. That's the state that we want to get to. There is no telemetry coming back. So these are the four kind of main focuses for now. If you want to look at additional complementary standards, things that I'm not necessarily covering now, but they're very, very much related, permissions policy, right? You've definitely got to go away and take a look at permissions policy, especially people familiar with passkeys, who's looked at passkeys or thinking of implementing passkeys. If you're going to be putting passkey support on your site soon, or you've already got passkey support on your site, you should absolutely be looking at permissions policy, because you can control, especially if you're pulling third-party script onto the page, what powerful browser features can that script access? And that includes things like the credentials management API for navigator.get for the creds. So you want to control like who has access to these APIs. And then it's things like the microphone. Who can request microphone permissions on my site? Well, on my site, the answer is nobody, because I don't have anything that needs a microphone. So you can lock out the microphone permission for your third parties. Geolocation, pretty sensitive one, right? Like, where is the device? I'm sure we've all been on websites and it pops up like the little, can we access your browser's location in the corner? It doesn't look good. If your third parties, ads, tracking, analytics, whatever, start popping these little widgets up, lock them down, close it off and say no. These are the permissions that we expect to use. which for us is almost none, and then the rest of them just lock them out. We don't need cameras, microphones, we don't need geolocation, we don't need local storage, we don't need anything. But take control of that and say it. The next two then control loading third-party dependencies. So co-op and co-op, as we've got, cross-origin embedded policy, cross-origin and opener policy, allows you to have more strict controls on when I start pulling these third-party dependencies, how are they allowed to interact, especially with my origin. So I have 2 blog posts on each of these. And again, they both have, all of these have completely safe testing modes, right? So even if you just want to deploy them in their report-only variant to say, everything is going according to plan. You don't have to take any enforcing or blocking action, but you can deploy them with no risk. And the final one is clear site data. Now, who's heard of clear site data? Okay, as we go through, the number of hands goes down and down, which is good because now we're getting some value out of this, right? So if you have users on your site and they, even if it's just the basic logout process, they delete their account, they delete all their data, you have to remember, okay, right, well, we've got all these cookies, we need to go delete them. We've got these things that we put in local storage for our application. We've got a service worker, we've got, maybe we've got some passkey implementation and we need to wipe all of the... Clear site data basically says, when they trigger this, when you send the clear site data header, wipe everything on the client to do with my site. And then you can't forget anything, right? You can't forget some cookies or tokens or things in local storage like that. So you just say, look, wipe the data. So on our site, when you go through the delete account process, we return the clear site data header, which tells the browser, just nuke everything. Don't leave any bits behind because we're not supposed to, and maybe we forgot something. All right, so you just clear site data, everything is gone, you can't forget anything. So it's just a nice tidy up policy, right? It's nice, quick and easy way to do this. Now, all of these things are current. This is all now, right? None of this is future speculation. These are all things that you could leave the room and go and do right now. They've got mainstream support in all of the browsers. This is not, theoretical. But let's take a look at some things that are, because we're not finished yet, right? There's more stuff coming. So one particular thing that I'm quite excited about, the one problem that I mentioned with SRI is that when you load it, you have to lock against that static hash, which means if you have a dynamic dependency, you can't do it. And that's kind of part of the problem. It's like, oh, well, we're loading dynamic code and we don't know what it is. Now, signature-based SRI is like a very happy kind of middle ground now, where instead of embedding the integrity hash into the script tag, what you're going to do is embed the vendor's public key into the script tag. And when the vendor serves the JavaScript file, they're going to sign the JavaScript file to say, this has come from us, it's not been tampered with, it's not been modified in any way, this is the JavaScript that we intended. So when the client pulls that script tag down, it can then verify the signature on it to know, has the vendor signed this JavaScript? Is this what they intended to give us, or has it been changed in some way? Right? And these signatures are static, so they sign the file, they drop it in their S3 bucket, and it sits there for months and months and months, and we verify the signature every time we load it. And then someone finally gets into the S3 bucket, changes the file, and as soon as the browser pulls that file down, it's going to say, well, the signature doesn't match. This isn't the file that they said they signed. Somebody's made a change to this. So now we're getting the protection of SRI, but we don't have the fragility of the JavaScript dependency needing to be static. So this is almost finished as a standard. We're currently testing this. And it looks really promising, especially for dynamic third-party dependencies, where you still want some sign from the vendor. This is the file that I meant to send you, right? We didn't make some changes by mistake or get compromised or have malware added to it. So signature-based SRI is going to be amazing. The second one, which is it's a little bit earlier, this one's a bit more out in the future. Oops, sorry. This one's a bit more out in the future. It's called connection allow list. So this is going to give you the ability to control any outbound communications from your page to a third party. So you're going to be able to give a solid list of these are the outbound third-party connections that are allowed. And it's going to apply to everything on the page. So if you say, look, my web page should only ever communicate with me and my domain, the browser's like, I got it, right? No outbound connections, no JavaScript XHRs to a third-party drop server. We've seen exfiltration via image requests, via DNS requests, using rel pre-connect and rel preload tags in the page. We've seen all kinds of stuff. And connection allow list will completely neutralize all of these exfiltration attacks. So these two are not yet final standards, right? You can currently play with SBSRI if you go into Chrome Canary. Connection allow list isn't there yet, so they are future. This is speculation, this is looking to the future. But it is going to be really awesome to have both of these things in the mainstream browsers. So look, to summarize things up, right? Like the thing that we have to do, first of all, get visibility. What do you have right now? What does normal look like? A lot of our customers, they don't go and review all of their third-party JavaScript, but they're like, look, you know what? We're pretty happy that things are good right now, so let's just consider this the good state, and we'll just monitor for change from this point forward, right? But you need that visibility. You need to know, what do we have now? When does it change? After that, you've got that understanding of what normal looks like. Change detection is the thing that's going to tell you there might be a problem. And maybe you don't respond to it. Maybe it's just a monitoring position. But at least you can go back in time in the data and peg when something started to go wrong. Hopefully you would respond to it more proactively. And like I said earlier, the whole point of this, I'm not saying don't use third-party dependencies. I'm not saying don't use other people's code. I'm saying that we can, and we can trust them to load code into our page, but we have to start verifying, are we getting what we thought? Is it doing what we want? And has it changed? So look, I wanted to leave some time at the end for questions, which I have. So I want to open the floor up now. I know we've had a couple as we went through. I appreciate that. I welcome the interactions, but I do want to open this up. We've got like 5 minutes, but hopefully there's a few questions. Yeah, hi.
What's the volume like of these reports? Because I'm thinking, okay, let's put this in, and I'll send it to an endpoint. I can imagine, depending on the website, it's going to be a lot of data.
Yeah, great question. I'll repeat just for the video. So essentially, like, am I going to get flooded with these telemetry items? Because if we're on a high traffic site, you're going to have like a high volume of telemetry coming in. Yeah, absolutely. Number one thing that I would do there is just inject the response header on a downsample of your responses. Right, so if you're looking and think we have like 5 million page views a day, I don't need 5 million people to tell me I have this JavaScript, right? So you just inject that header on like 1 in 1,000 responses. And then only 1 in 1,000 browsers are going to send you the audit, or 1 in 10,000, 1 in 50,000. But you can very quickly and very easily control the volume of telemetry that's coming back by only injecting the header on what you deem to be an appropriate downsample. Good question, yeah. Like, you can get a lot of telemetry out of this if you do it wrong. Be careful. Yeah.
Some of the third-party JavaScripts you load up, like say a user feedback form or something, that JavaScript doesn't actually need access to the rest of the information in the doc.
Yep.
So it's just the interaction between the user and whatever that JavaScript is. Can we use, is there some sort of can we use sandboxes and frames?
Yeah. So again, yeah, just for the repeat for the room and the video, we're pulling that script into the DOM. It gets full access to the DOM. Is there any way that we can isolate that script from having like full DOM access effectively? So yeah, this is when we can start looking at things like iframes with the sandbox attribute. So if we've got our chatbot, we might not drop the chatbot script straight onto the page, right? We might push it down into an iframe and then sandbox that iframe so it can't reach back out into the parent context. So it's possible, it's just not, I mean, literally looking at the data, like it's not what people do. You know, people take the script tag, they drop it on the page, and away we go. So there are safer ways to do this. There are safer ways to introduce script and put even more controls in place, like push it down to a child browsing context and say, you stay down there and you don't touch anything. It just requires a bit more effort to do that. Yeah, like you have to do what you do now, but in a slightly different way, in a slightly more security-aware way. So it can be done. You absolutely can isolate these things. It's just a bit more tricky. And I struggle to even get through the initial conversation with a lot of our customers, and instead they're like, no, we just want to put it in Google Tag Manager and stick it on the page. And I'm like, okay, well, you know, we have to work with what we've got, but you can do that. It's a good question. Yes, here in the middle.
It's a no-brainer to add SRI hashing, right? Should you be worried about the timing of when you break the hash? Could you be unlucky and get hashing at this time that it's actually?
Yeah, so when we take a file and we hash the file to put the SRI hash in the script tag, what if the file is infected at that point? Effectively, you know, so you're saying, what if we lock to an infected version of a JavaScript file? Yeah, absolutely. And this kind of goes back to a lot of, the true way to solve that problem is to review all the JavaScript, right? And I'm not going to suggest that because it's a silly suggestion and nobody's going to go out there and review like 1 megabyte of third-party JavaScript. So there is kind of a component of this where we're saying, look, we think that everything's okay right now, and we're going to set this as the start point. And really what we're looking for is change detection going forwards. Unless you're going to actually go and review that third-party code, you can never know, is this script infected right now? Is it doing something that I maybe it's not even that bad. Maybe it's just a privacy concern, a performance concern. But unless you actually go and review that code, what you're saying is, I assume everything is good now. Tell me if that changes. But you're right. Like, it's a fair point. But that's the kind of balance between security and ridiculous advice, like review every line of third-party JavaScript code. But it's good. I appreciate the question. Yeah, so when SRI became super popular, kind of like 2014, 15, when all of those big attacks started going, we started to push a lot of the large CDN providers like the jQuery CDN, Max CDN, CDN JS. We started raising tickets and pestering them to provide default script tags with SRI included. If you look at some of the issues on their trackers in 2015, you'll see me hounding them to do that. Because it's a free, easy win, right? People just copy and paste the snippet. It's already got SRI. Nobody needs to know about SRI. But you've got the protection. There's a question here. Yeah.
About the signature verification, so maybe we get you a bit ahead. But this requires that the vendor does something from their side.
Yes.
So for a company, it's probably not a problem. How easy would it be for JDO writing out this open source plugin to implement it?
So, yeah, good. I'll repeat for the room. So when we go to signature-based SRI, we're now requiring the vendor to have this additional process, which is to sign the payloads. So yes, and just to be clear, like they only need to do something when the file changes, because they only need to generate a signature when the file changes. So we still plan to see lots of people like generating that file, pushing it out to a CDN, and then serving it from a CDN, because the signature on the file is static. It's still perfectly well suited to caching. But yes, the vendor is now going to hopefully have, some kind of like TPM or HSM on their side where they can store the key properly, because now we need to store the key properly, and then generate the signatures. But it's only at build time for the file, right? So the signature generation is just a one-off thing. You stick the signature on the end of the file, and then we can go back to our third-party CDN caches. So yes, there is an additional process for the vendor, unless they're, pumping out 50 versions of their JavaScript a day. It shouldn't be overly burdensome for them to do that, but there is, yes, an additional process for the JavaScript vendor. Maybe time for one more. No more. All right, thank you very much, everybody.